Okay, so today we're gonna talk about graphic track. I will explain the definition in the most simple way, and I want to demonstrate to you how it's work. And I also explain the paper, so I hope that you can all understand and provide me with quality questions. So let's come to the definition of graph. So you all know graph when you learn computer science, right? It's node and edge connect together, and the node is can be everything. Like for example, I have here this is a node and this is an edge. I name it. Okay, you can consider the from and the line is a weight between the edge between node. So in here I have an example. This is a graph, and the next definition will be a little bit complicated knowledge graph. But here I just want to remind you of the simple concept first. Node edge, the edge can have the weight. Okay, mostly they in the number, but in here I leave it in the text. That is okay. And the node has a name as well. So this is how we represent information as a graph. But what about knowledge graph? Knowledge graph is a bit more complicated. It's still the node, the edge, and the connection between them, but they have informations. Both the node and the edge has the information like human. They can have name, age, job, country, what they like, hobby, yeah, and the food as well. Name, ingredient, taste, rating, and the relationship between human and food. The edge can also have the attribute with the level 1 to 5 or how much, how frequency. So these things they can all be defined, and that is called knowledge graph. There's many examples of knowledge graph that I can show you. Like for example, in this case, I have the data set. It's just about movie and person, and this is an example of knowledge graph as well. The actor, they have the bond, they have their name. The movie, they have their like released tagline is a quote in the film and the title. So they define this thing is defined already by human, and the relationship between the actor and the movie is also mentioned. I mean, the human and the movie, because not only acted in, but they also like directed. They have many type of relationship, a lot. So the an example of knowledge graph is a way of represent information, but in graph form. So now you may have understand how to represent information in graph type. You may wonder what is graph with rag, what we're gonna do about it. So I also talk about rag. So it's very simple. Um, when you pass an input to a LLM, right, you receive the output. But the quality of output, it depends on what inside the input. Like you may have your prompt, you may have your user query, but the information that highly relevant to user query may also decide how effective your LLM. So how do they do that? How do they know what is a relevant information that have a high similarity with the user query? Well, they have the source, right? Maybe in the table type, maybe in non-structured type, and they may use some natural language processing technique to compare to take together, like embedding, word embedding, um, by lexical, like level stand distance. So they have a lot of technique to compare two text together to find the top K relevant information, then pass into the input. So it's a traditional way. It's a traditional way, and a lot of us know it. So what is a graph way? Yeah. So To query the information in GraphWay is a little bit more specific. So you still have, the user query, you still have it. But the first step they would do is they extract the keyword. For example, the metric director, this is the entity, this is the actions, or sometimes we call it relationship. And when we have the keyword, right, we have the keyword. So what we're gonna do, we're gonna match the keyword with the node and the relationship in the database. For example, I match with this node. How to match it? Simple. By semantic, lexical, we have a bunch of options from embedding to, traditional approach. So this is a simple way, a very simple way. But there is a problem. What happened if, like your node doesn't connect it directly together? For example, I have this original question, right? Is A has the same role as B? And of course, the keyword is maybe A, B, and maybe, row or something like that. So now, when I match, right, I know A is here, B is here, but they are not connected together, right? They are not connected. What do I do? Um, at this time, it's totally normal, okay? You can use your algorithms in Graph to connect two nodes together by finding the shortest path. And there's a lot of algorithms that do that actions. So when you're able to connect all of your informations, you had a knowledge in a structured way, have the context and connect it together. Yeah, but you may have a questions like, how do I do it well? So of course there will be a lot of questions later, but here is some main questions. First question is, how do you organize your data? Like you may have seen an example about the knowledge graph, right? About the movie, about the human, and you may see it a lot of example later. So the way you define your knowledge graph is very important because it may affect everything later, like how effective is your retrieval, how fast do you query, they is the most important things. So let's assume that you have your knowledge graph, okay, or a normal graph. That's okay. So what's the next thing? Like, what is your methodology to, search? What is your strategies? Like, you can use a lot of algorithm to connect or not together, right? You can increase the, the search, like search in a larger scope, but it even though it connect everything together, but it may increase in the information and both in the speed, the time, and the resource as well. So you need to search some paper. It will show you how to do it well. And I also have one example for you. And the third one is, okay, this is not a new problem, right? There's many open source, many paper. So what is the important things like the component? So you can build your own rack with Graph. So I will explain that later. Now, I will introduce you to a paper, a very, I think, easy understand one. You guys can search this name. I will put that in the Google Meet. I put here. Okay, so let's come back to the paper. So this paper is introduce how to, organize the data in a knowledge graph form and how to query them like with graph thought prompting technique. So of course, the data set used in this data is related to medical data set. It's very complex, but they still able to have a good result. And the most important things is Some user query is it dataset contains false information, but somehow maybe the technique is too good. The model is able to know it. Like maybe they organize the data is too good. Well, because I have read this paper, and I think I can explain that to you in very easy way to understand. Let's come to the appendix sector. Okay. I hope you all see well because I have, read a lot. So first, like I said, they have the questions, right? Normal questions. They extract the keyword is the first step. Liver problem and other symptoms. So they will know that, oh, okay, there's a lot of note here, right? They have a set of note. So what they do now? How do they connect everything together? So the step is simple. The algorithm is demonstrated in the figure below. So, but I can explain that to you in an easy way. So assume that I have a set of nodes. So I will try to build an algorithm to connect each of them together node by node. Like the first one, I connect node V1 with node V2, right? And if I connected successfully, I will move to step 2. I will connect node V2 with node V3. And let's assume that this is an easy case. I connect all of them. I have the path. Yeah, but things is not that easy. Assume that, okay, I use able to connect node V1 with node V2, but I can't use node V2 to connect with node V3 and V4. Like they are separated. So how do I do? Well, I have to, change the node. Maybe this time I will not start from node V1 and node V2. I will start from node V3 to connect to the other node. Yeah, okay, let's do that. But what happened if in the last they are still not fully connected? Like they can have some small subgraph, right? So let's look at the blue part in this. So the node has its neighbor. They are connected to other node, right? So in this paper, the outer demonstrations, one hop exploration of a node, like a node will connect to the nearest node, right? Or you can decide to use 2 hop, 3 hop, 4 hop. So a one node can connect to more node, like for example, uh, let's the green mine. The one hop node that connect to the green mine is, this actor, this one. But you ask me what the 2 hop node that connect to the green mine. This one is one, this one is two. Yeah. So by increasing the hop, you can find more neighbor node. But of course, increase the complexity of time and you know area. It take longer and need more resource. So this is the most fundamental concept of how they do that. They will try different variants to connect everything together. And after this presentation and some demonstration, and you will see that the most important things beside how you organize your data is how you build your strategy to search. Well, that is the most important thing, and you will feel it. Okay, so let's see. So let's assume that they know how to convert a document into a knowledge graph. So how do they from a knowledge graph to retrieve the answer, right? They also do that by just matching things together and connecting together, right? What happened after that? Because you know that when they have many subgraph, They must combine them together to remove redundancy and, of course, to make it look more neatly. So after they connect them together, it would be look like this. Is the original input from user query, right? After you query from the knowledge graph, it may look like this: node relationship, node relationship, node. Yeah, of course you have to, remove redundancy. And after that, you may see that there are some structure, very some structure. And you can, from this step, you can use your prompting technique to continue doing your task. Like grab a thought, it's not something that too complicated. The complicated thing is the retrieval process. You just organize things together, like you convert that connection and node to some small text and continue to process. That's okay. In this case, they use a decision tree, but well, you can do a lot of things. You don't have to fix and into anything. You can decide your model, your strategies, how you build your data. You search. Okay. So maybe in this step, you may understand a little bit about how things can work, right? I hope so. And this is a very good paper. They provide many examples. And if you look at, the result, you will see that they demonstrate it over mainly uh, baseline modules. They have also a lot of data set also. Use different modules. BM25 is traditional technique, embedding, well, classical one, and they combine everything together to see what's the best. Okay, maybe you can read about this later. So maybe we come to the demonstration process right now.
But before that, I have a question.
Okay, okay.
Yeah, so I want to ask about the the process of building the knowledge graph from the extracted keywords. So
Okay.
from the original question, we will extract only the important words, right? And we ignore all the stop words. Is
Okay, I understand the questions.
Yeah, so we
Um,
ignore all the
yeah,
stop words. So how
they
how about the problem of lacking the global context? Like some stop word will provide us more context. For example, the the stop word, so that, right? They will
so that, yeah,
it
okay,
will
so that.
provide us more context about the conclusion, for example. So
Okay,
how about the problem of lacking the context?
understandable. So, if you use name entity recognitions, maybe we will lose a lot of context. So in this case, they also integrated LLM maybe the first step right away. They use LLM to extract the questions. Of course, the efficiency is high, but also have a cost. But in some research about, let me show you, it's called modular bracket. In this kind of, uh, I'm not sure is this paper or not, but yes, okay, it's that paper. But you see that in this kind of paper, modular bracket, they are very advanced way because they know that the query from user is diverse, have a very different context. So what they're gonna do? Well, they may have a small modules of LLM to extract the important information from user query before transforming into graph. Name entity only extract important keyword. It may lose the context, but LLM may don't. But it also depends on how you define your prompt. Of course, there may be still some abstract informations. So how are we gonna show abstract information and both the specific information and abstract information? In that case, I suggest you read one more paper. I think I have downloaded. I also read one about light rack. Well, the community said that this one is better than grab rack. I haven't really tried it yet. We still in the time of investigate. I haven't tried on the future yet. Just try some easy function. So in this methodology, they have a part that where they have this one dual level retrieval. Yes, your problem has been considered, and there's many methodology to do that. I think if we want to have a more robust retrieval method, we need to compose more informations. So yeah, they have abstract query, they have a specific query. Yeah, a lot. Yeah, yeah. Sometimes we don't have fully connected between keyword.
Uh, so if we do not have the fully connected, so so we will combine subgraph together, right? To get the
Yes,
fully.
we combine subgraph together.
Yeah. Okay.
Exactly.
Okay. So one more tiny things is that can you tell me more about the hop, like one hop and two hop?
Okay, okay. Maybe this term may be new. So I have this node named green mine. One hop is a hop that the nearest to green mine, like this one is near to green mine. This one David Moss, but two hop. Let me check. Okay, this is one hop Tom Hanks to Green Mile, right? Tom Hanks acted in the Polar Express. So the Polar Express is a two hop node to the Green Mile. Yeah, it's very easy to understand. So yeah, yeah. You can understand like that. Yeah, all right. Yeah, so they try to expand the connection to see if they match anything. And if they match, they connect things together, remove redundancy, and have the final graph. And that is how, if we read the first paper, the MyMap GPT, this one, we will see that the model is able to detect false informations. Like in this case, it's about medical, right? I have a feeling, some symptom, I think, blah, blah, blah. So they can connect symptoms together. And of course, somehow they be able to detect the real disease and avoid the false one. It's very amazing. Yeah. But depend on how you build your knowledge graph. In this one, they just build a quite normal graph. When I say a quite normal graph, I mean uh, it's for general purpose. The node doesn't have the informations and the edge is answer. But in some case, um, when you represent your data, the knowledge graph contains more, information, like the movie one. And yeah, the movie one. So in this case, things are more a little bit complicated. You may need to spend more time on develop your query and your strategy as well.
Yeah,
Yeah. Any questions before we move to some little, demonstration? Just ask. Okay, okay. If we don't, have any other questions, maybe we'll go into the next part. What is a component and how, if you like, how do you want to custom your own modules? So let's start. Okay, so here you just need some, library. You don't even need this. Sentence transformer is used for embedding if you like. If you don't like what embedding, you can use traditional method like TF-IDF, BM25, Lagrange stand distance. Yeah, a lot. You also can use Neo4j for graph database. If you don't want to use Neo4j, you can use Network X. Okay, and a model. This time I use Google Generative Gen AI. You don't like, you can use local model, DeepSeek, OpenAI, anything. You can change anything you want. So here is how I connect to my Neo4j, right? I connect to it, I embed the node informations. Yeah, but I see that in that case, I don't have to embed. Yeah, it still work. It depends on your strategies. Okay. So the most simple way, right, is you have your LM, you have your database, you have everything defined. So you think about, how about I let the LM decide itself? Like just make it query the information for its ears. Can it do that? Well, in this simple way, it can do that. Like I asked with movie that this actor act in, it still be able to query the information because it's a simple one, right? LM how not to write code or how many actor acted in the magic movie. Of course, it can answer. Do Keanu Reeves know this one? And yeah, of course, it's still return. But like I said, uh, sometimes LM generated query may have obstacle. It may have some struggle, not able to query information. But I suggest that you implement a methodologies from paper or maybe just bring it from the open source. It will be much better. It's just some demonstrations, some little. So we may have some experience because I know that there are something that may make you struggle a little bit. Yeah, just a little bit. Now, I make things a little bit complex. So now I still, extract entity, the first step, right? I find related part, I mean the shorted part to connecting together. Uh, this case I use for person node. I haven't developed a query that can connect every label node yet, but it's just a coding problem, so it doesn't hard. Just give me time, and maybe in the future we have that. And now, this one just connect two function above together. And the final one is I generate response from the information I got in a Neo4j. The prompting is quite simple because I haven't improved it yet. But you can, if you want to improve your prompting, I suggest that, you go to open source, light grab rack. Uh, yeah, this one. There's a GitHub right here, and you can go to the code. I know that they leave prompt somewhere. I have seen it. Let me check. Just somewhere. Somewhere in here. Maybe I just should use OS library to find me some, prompting, but they just live somewhere in here. I just don't remember where they live their prompt. But yeah, just use OS library somewhere. Yeah. So you can use a prompt to, to custom into your own problem. Okay, so let's just come back to the demo. Now, as this prompt, I asked my query is find connection between three actors, right? So when I send query like this, uh, my functions, it will extract the entity and it will search in the database about their connections. We can try the query right here and let's see what happened. Let's try it right here. After trying, you may see that why GrabRag is good when you define your problem well. Okay, let's just look at where that I can. Okay, so you know that this is the connections between three actors. Okay. Oh, what? Okay, I just need to run this thing back. Okay, but you know, actually they are a little bit far away. Tom Hang is where Tom Hang and connected Frank. Tom Hang and Frank is connected together very close. But if the director doesn't have any connection with this actor, Madonna, but you see that by the algorithm, you have been able to connect things together. And I just implement very simple one. Find the shortest path between each of node and combine them together. Remove some redundancy. It's not the implementation of my map paper. It's just a simple algorithm that I coded for demonstrations. And still able to retrieve the information. Still good. After got the information, okay, maybe this is because I asked them to find the connection. So in the last answer, they build this connection for me. But if I ask more like detailed questions, is Tom Hanks older than Frank? Yes, Tom Hanks is born in this, and the other was born in this year. And you have seen that, you know, Tom Hanks is a key, right? Frank Darabont also. But the older than, I don't have that word, right? I don't have that word yet because in this knowledge graph, we only have the born attribute. But how they still able to work? Well, because I have able to retrieve the connection between Tom Hanks and Frank. And when I pass the information to the LLM, they already got like, uh, this one. They may had to look. Yeah, they have this. Okay, because of the embedding problem, they are quite hard to look. But I can tell you that they have the information of the node Tom Hanks, the node Frank, so the LLM can access to the information. That's why it can answer the questions. So that's how they work. That's how they work. Or next time I ask another questions. Tom Hanks has the same role as Frank. Okay, again, what is a role here? There is no terminology named role in this knowledge graph. It's just, uh, Just some relationship like this. How we still know? Because the entity has been able to be extracted. And of course, because it's a well-defined knowledge graph. So yeah, of course, we still know how to do it well. But if you ask me, okay, Chong, is it perfect yet? No, not yet. Just not yet. About this problem, you see that, okay, this one is a simple question, right? How many movie does Tom Hanks acted in? And when I use the above algorithm, you see that, wow, there may seem a problem here because there is just Tom Hanks in the entity list. So there's nothing such a shortest path, right? The algorithm fail. There's many other cases that the algorithm might fail, like too many label nodes need to a more sophisticated query, or sometimes uh, even though you may retrieve the owner of the information, but it's too large, and LLM can be hallucinate about that. But you know what? This algorithm, the first one that I show you is able to answer it. Yeah, the first one, that the simple idea one that let LLM just decide for themselves. So, okay, what is the conclusion we have in here? As a conclusion, just very simple one, is that GraphRag is robust when you define well your data structure. However, there are some problems, obviously problem. The process of converting a document to a graph type um, is, very hard work. It needs the precision. Like some abstract word, it may not consider a relation. And in this process, if you use name entity recognition, will it work? Yes. High accuracy? Not sure. If you use LM, of course, it will work. But the cost is higher. The next step is the algorithm to retrieve the information. How do you build your algorithm? What open source, what paper that you infer may decide your result. If I able to, copy, or I said modify the open source retrieval algorithm, maybe I will have a more robust technique. Or if I able to implement some algorithm of some paper, it just need more time. You have a good result. And the next one is, that you define your graph, right? But you may need to update it. You need to update the information. You need to update maybe even the structure of the graph, like the type of node, the type of relationship. So if you update it, then we change the algorithm. How do we maintain it over the time? It also a questions, a hard one. So okay, this may be a brief look into the graph rack. Do you have any further questions about how things may work, or you want to know anything else? Simple, right?
Yeah, and and so I understand that we have three main steps. The first one is extracting the keywords. The second
Yes.
is build a graph, and the
Mm,
third
okay.
one is feed the original question and all the graph information to the as the input for the LLM, right?
Okay, that process is okay, but there is another process. Is that like I said, you define your own graph first. Then you extract the entity according to your defined graph. Then you still build the retrieval and you aggregate information together. Yeah, and you maintain it later. So yeah, it depends because in this paper and in the light rack paper, the document is in text form and is an original document. So when they build a knowledge graph, I think I don't think that it's a knowledge graph yet. It's just a graph of informations. It's very simple to retrieve because you spread all of the information. But if the thing that you build is a knowledge graph, like your existing system, then the story will be a little bit different. You may need to consider more, carefully. I said more carefully.
Yeah, thank you. And you've just mentioned about that the paper, the mind map paper, uh, not build the knowledge graph and build the graph instead, right?
Yes.
So I understand that the main difference between graph and knowledge graph is that the graph just have a name of the node and does not contain any other information about that node, right?
Yeah, you can understand. That's right. That's right. Knowledge graph is contain information in both node and edge. Normal graph don't.
Yeah. How about the accuracy and speed? Like if we
Okay.
um like um like the speed maybe faster than any rack method, right? But how about the
Okay.
accuracy?
About the terminology of speed, yeah, I would like to say about this. So when we have to build out data in the graph type, if you will not be fast at we retrieve it in uh, table type like the normal one. So, but of course, you can improve it. Uh, if you decide to spread all of your node information into node and edge, then you have a lot of node, right? It may affect it how do you choose the hop number. But if you build things in knowledge graph, then the hop number you just let it be 4 and you still retrieve a lot of information. But then you have another question. How do I retrieve specific informations? Age, um, job, country, like that. If you spread all it over like a normal graph, you just need to matching the keyword with the node. That's it. But if you build a knowledge graph, you will decide that, like how I match with detailed informations. They have both advantage and disadvantage. The first one is more simple. The second one is hard, very hard. But if you're able to control it, it will be very robust. Yeah, smart, smart. Any other questions? Easy to understand, right? Yeah, very easy.
I have another question.
Okay.
Uh, as you say, Graph has a way of organize data in a node form. Uh, I think it's similar with chunking uh, in basic graph, right?
Yes, it may share some similar in concept.
Yes. So, what do you think? Do you think the graph need chunking, and when chunking is needed?
Okay, okay. So about these questions, if you look at the open source of, I said that Lightrack, I choose. There also a real graph rack, but I don't mention it in this presentation because the community said Lightrack is better. So in the Lightrack, the when I see one of my workers, they run the code. They in the code of output from query to graph form is in the XML form, and I see that they're on the chunking. They have the chunking in these methodologies. So when to chunk? Well, of course, we need to chunk to narrow down the informations because if I put in a book, right, a book, there will be a lot of information and consideration of connection between every entity in a book together at the same time. It will be very hard. But let's assume that I chunk each part of the book like according to a heading and table of content. So the content is related together, right? Then we form a subgraph. So each heading or each content in a table of content form a subgraph. Later, I can combine them together. But now, we may ask a question. How do we chunk? 5 rows, 7 rows, heading, table content? That is a very important question. Depend on the type of content. PDF, I think the heading, table content is good. But normal text, maybe it should be the sentence. If it's a paragraph, right, we should chunk by sentence. So it depends. We need to chunk, right? Need to chunk. Okay, ask more, ask
Okay,
more.
okay, thank you. Oh, I think I have another question.
Okay.
Um, my last list questions about someone say that when the node and data became very large and complex, uh, someone on Stack Overflow told me that I should train the model. What do you think about this view?
Uh, okay. I want to ask more specific. Train a model. What model and what it does.
Uh, I'm host the local model in my
Uh,
computer.
okay. It's a local LM or local embedding
Yes,
model. Okay, local LM.
LLM.
So understandable. So you know that recently we have DeepSeek, right? DeepSeek.
Yeah.
So what about what I can do? Like you can use LM Studio or Olama to train it and run it. About this opinion, I think that they suggest a great idea. Like not any way, not any time that we can use API, like with the data with a high privacy and need to be protected. Maybe we just allow it to process in local machine, understandable. So I think using DeepSeek is or other local model is okay. Well, because I haven't read all the configuration of Neo4j yet, but as you see a demonstration in the code, every component can be replaced with what you need. You don't like the embedding model, you like to pay, use OpenAI, or else you free. Using local model can do a lot. Like they will know your graph rack together a lot better if you train it. And you can use many times as you want. You can use it 2 time calling, 3 time calling. Like the method mentioned in this modular Raga. Modular Raga is a system. There are many retrieval methods based on this system. They spam LM to make it better. And you can, spam your LM, retrieve everything possible and aggregate it later. Else I remember something. Uh, okay, maybe it's about the code. Okay, I still remember something. Okay, in this code, you see that I use LM a two process. The first process is to extract the entity, important keyword informations from user query. The second step is after I, retrieve all the informations, I compose the informations. And you will see this is implement a lot. And some people, they even use more time LM than me to retrieve the information, do everything to get precise. So local one is good. Less money have to pay, but have to maintain it in a maybe good hardware.
Okay, thank you. As you say, training model can help it um, understand more about the pattern and reasoning. Thank you.
Okay, and any other questions? Okay, maybe we understand everything, right? Uh, okay, if we have no other questions, maybe we can leave it later in the next seminar. Just ask me, okay? So maybe it end here, guys. Maybe it end here. Okay, bye.
Yeah, thank you.